Okay, saya tengok macam, let me see how many people. Okay, all right. So, okay, I know most of you are still in mood raya, but life needs to go on. Okay, so no matter what, we need to continue with our normal life, right? So, and I think everybody is a kind of, rasa feeling much better after this first May. So the SOP is no longer as strict as before, and kita tak perlu pakai mask and so on. But I just want to remind everyone to make sure that you take care of yourself, stay safe, and I'm still wearing mask no matter what, no matter dekat tempat yang crowded ataupun tidak crowded. So because we need to be very careful and take care of ourselves. Alright, so hari ni just to actually I'm in UTM KL at this moment because I need to attend workshop until Tuesday. So I'm already here in UTM KL. So siapa yang rumah kat KL tu bolehlah ajak saya pergi beraya ke apa. So boleh saya makan free ke, makan kuih raya. Okay. Right. So anyway, there are a few things that I would like to announce before we start our lecture today. So the first thing is on this coming Wednesday. So we are going to have our first quiz. Okay, kita dah tangguhkan our quiz for many weeks actually. So we are going to have our first quiz. So I'm going to most probably the quiz will be online. So you need to enter the to log in the e-learning and answer through the e-learning. So if it's e-learning through e-learning, so it's going to be objective questions, okay, multiple choice, and then you need to submit through e-learning, and the time will be given to you to answer the questions will be 10 minutes only, right? So it's going to be very simple questions on the theory only. There will be no calculation at all. If there is a calculation, so it means that you can use your fingers or your toes to calculate, right? So you don't need a calculator to do the calculation in that quiz. But you need to be familiar with all the theories that we have learned in order to answer the question. So basically, I will let you know, okay, inshallah by tomorrow, how many questions, okay, and also what kind of questions will be in the quiz. Okay, actually the quiz is already ready, but I need to go through it again, all right? Okay, and then that one, the first thing regarding our quiz, and then the second one regarding our online classes, okay? So I will remain our online classes, okay? Either on Sunday or, other day. So till week 10, because I need to arrange our classroom with the admin, the faculty admin. So I will let you know the room that we are going to have for our physical classes. But we're still we'll still have class on Sunday as usual for 2 hours, 11 to 1. It's just that for 1 hour class on Wednesday, and also, is it Wednesday and Thursday, right? For depends on your section. So that one I will let you know but as soon as possible, and we'll start that physical class in week 10. So just be patient for the further notice, okay? Right, so anyway, so for today we are going to do chapter 6 and also chapter 7 if we have time. So the first hour will be on chapter 6, and then the second hour will be on chapter 7. So I need to be a little bit, apa orang kata, I need to catch up, okay? Because we have too many holidays before, and I hope that we can replace some of the classes when I see the time is right for everyone, right? So let's go to chapter 6 now. Okay, can you see the screen? Can you see my slides? Yes or no? Okay, thank you, thank you. All right. Okay, so chapter 6 is on estimation. Actually, we already discussed this one in chapter 5, okay, before Raya. And so I already explained to you, okay, what is actually estimator. Estimator, other name for estimator, also known as statistics, okay. So basically, the estimation, all the chapters that we are doing now, okay, we have done in our previous meeting, and also the next one is going to be on inferential statistics. Okay, when I mention the word inferential statistics, it means that whatever we do, okay, when we do our study, we must have a sample in our study. So that's the reason we need to use whatever information that we get from the sample in order to estimate the real actual number or the actual statistics in for the population, right? So that's what we call it as estimation. When we have a sample, right? When we have a sample, we want to estimate the population, right? So that's what we are going to do. This is what we call it as inferential statistics. Okay, so in this case, what is actually an estimator? I also mentioned this one before in our previous meeting, that one of the very important estimators in inferential statistics is the mean, right? So we get the mean from the sample, which is called as X bar, where we need to estimate the actual value of mean of population, which is mu, right? So that is our job, to estimate the value of mu from X bar from the sample, right? So again, so we have mean X bar, and we want to estimate the mu. Why? Because we hope that this, right, the value should be the same, X bar or mu, right? So this is from the population, and this one from the sample, right? So that's our job, right? So for example, a consumer wants to estimate the average price of similar homes in a city before putting her home on the market. So for example, your parents want to sell your house, okay, because you want to get a better house, all right? So in order to estimate what is actually the best price that you can sell for the house, what you can do is to do research, okay, a mini study, right? So where you can get all the prices of the houses in your area. Okay, so for example, in your taman in your area, so you have 20 houses, right? So you get some of the houses might be have been renovated, might they have did something to the house, so the price might increase a little bit. So what you can do is actually you can get all the prices in order to estimate the best price for you to sell the house and put it in the advertisement. So let's say you get 20 houses, okay? So the houses in your area, for example, might range from 200,000, okay? Sekarang ni no more 20,000, 200, let's say to 500,000, okay? So in this area, so what you can do, you can ask, the property agents to do the estimation for you for each houses, or maybe you can ask the owner how much is actually the value of their houses. Okay, so the 20 houses, the range is 200 until 500,000. So you can get the price from each house, and then you add them up and get the average of the 20 houses. Okay, so the price of the average price is actually what you are calculating is the X bar, right? The mean of the sample from 20 houses. So therefore, let's say after calculate the average price of the 20 houses, you get actually the price is 220,000, right? So we hope that actually this 20, 200, okay, 220,000 can represent the price for all the houses in that area. Okay, so this is what we call it as estimation. So you need to estimate the average of the home prices. Okay, so there are two ways of estimating parameters. Okay, when I say the word parameters, what does it mean? Okay, I also mentioned this one before, right? Parameters are actually the value that you get from the population. So for example, you have mu, you have big N, you have sigma, and sigma square, for example. Those are actually represent for parameters because we use all these values for population. And if we use the same value, okay, the same purpose, but for the sample, we don't call it as mu. Instead, for the sample, we call it as x bar, s small n, s small s, and s square, okay, to represent for the sample. So this one is statistics or estimator. Right. So we already did this one in chapter 5. Okay, there are two ways of estimating parameters. So in your syllabus for your class, what this parameter that we want to estimate is actually mu, right? So we want to get from x bar, we want to estimate the mu. So there are two ways of estimating mu. The first one by using estimation. The second one is hypothesis testing. So hypothesis testing is one of actually very popular ways of doing estimation, right? So, okay. And there are two types of estimation. The first one, we call it as point estimator. The second one is called as interval estimation or estimator, right? So on page 69, right? On page 69, okay, I would like you to copy down this one first, okay? The definition of point estimator, and then I'm going to explain what is actually point estimator is. Okay, what actually point estimator is. All right. So point estimator, a single number is calculated to estimate the parameter. Okay, can you write this one down on page 69? Okay, so once you're done, let me know. Okay, thank you, Anong. Right. Thank you, Roha. Thank you. Okay, Johannes, and so on. All right. So point, the word is point estimator. Oops. Okay, the word point. So point I estimated, it means that when you give the answer of your estimation, you only give one number. That's what it means. Okay, just use a single number. Remember, our purpose is to estimate the value of mu from x bar, right? So that's our purpose. So when I say what is actually the average price of the houses, the 20 houses in your area that you have found, okay? So you give the answer is RM 220,000, right? So your answer is only one number, okay? So that's what we call it as point estimator. Usually, people, when they give just answer in one number, one single number, it means that they are very confident with the number that they have found, right? So that one is point estimator, right? So you can say the average price of 20 houses in the area, or the X bar, is found to be 220,000. Okay, but what happened? Okay, what happened if people ask you, okay, what is actually the average price of the 20 houses in your area? You are not very confident with your answer, okay, because some people, they may have renovated their houses, they may have done something to their houses, which may the owner also not sure what is actually the value of their houses, for example, okay. So we also get, the information from the owner, where they are also not really sure. They are also estimate their, their house price. So for example, when we ask, okay, Mr. Tan, how much is actually the value of your house this year? So Mr. Tan cakap, oh, actually I have done quite a lot to this house. Maybe it's about, like 350 to 400, maybe the market value, right? So what happened when we are not confident with what we are going to say, right? Usually we are not going to give just one single number. Instead, we prefer to give it in interval, right? So we use two numbers in order to give the range, right? So this is known as confidence interval, or CI. So for example, Mr. Tan just now said about 350,000, okay, RM, till 400,000, okay. So this person, Mr. Tan, only confident that the price will be within this range, okay. So this is what we call it as lower bound, and then this one is upper bound, right? So for example, the same thing when your friend said, okay, um are we go what time are we going to nak pergi raya? Okay, let's say to go for hari raya lah, to your friend's house. And then when your friend very confident that he or she wants to go at 3 o'clock, okay, let's say 3 petang, 3 p.m. So your friend will say, oh, we'll go at 3 p.m. Okay, but if your friends have something else to do and not sure whether exactly the time that he or she is free, then she or he will answer, or maybe we can go, like 4:30, maybe 5. Okay, so what happened? Your friends give two numbers instead of one single number. Faham tak? So that's the difference between point estimator and interval estimator. Usually when we give, uh, we are very sure, we are very confident. Usually we will uh, we will produce just one single number to represent that we are confident with the estimation. All right. If we are not very confident about it, usually we are going to use two numbers instead of one number. Faham ke tidak? Okay. And then it is very important, okay, for us to know what does it mean with unbiased and biased estimator. Okay, remember just now I said that when we do our estimation from x bar to mu, we want to get the value of x bar and mu similar ataupun same, equal, alright? So that's our aim. But there are sometimes in our real life it's not easy to get that, right? Sometimes the sample that we get cannot exactly give the exact number of the mu in the population, but it is close. For example, the we get, all right, so okay, for example, X bar, okay, we get 220,000. But the real mu, when we, let's say, this one is from the 20 houses, right? So let's say in that area got 100 houses. So when we calculate the whole 100 houses, actually the mu is like 256,000. Okay, 250,000. So in that sense, we can see actually our estimation is not really biased. When we say biased, it's like, when the mu is like 400,000. So it means that the real value of the mean is very, very far away from the actual that we get from our sample. So that one we call it as bias. So for example, in this case, so from the population, so it's supposed to 400,000, but from the sample, so we only get, like 220. So what happened from here to here, this is what we call it as error. Okay. So, but we're supposed to get something very close. So, if like, the population is 256, so this one is quite close, all right? Okay, quite close to 120. We still can accept and we can conclude that the estimation that we have done is unbiased, right? So the margin error is when we have bias estimation, all right? So the one that I mentioned just now, okay? So this is what we call it as margin error, okay? Ataupun we can call it as estimation error. So the margin error of estimation error occurs when we don't get, the mean, right? The mu, the number of mu does not either this way ke x bar kat sini ataupun we can get the x bar here, right? So but the value of x bar and also mu is quite far apart. Okay, so that's what we call it as margin error. So all right. So usually what we did, okay, that this 95%, okay, we always say that we want to be confident, all right? We want to be confident in whatever we give answers or we give our estimation should be more than 95% or 90% confidence level, okay? So we are going to talk about it after this, right? So again, let me just mention, okay, point estimator, remember only one single number, okay, so in our case will be our x bar, right? So that's will be our point estimator. And then just now I mentioned about the margin error. So when for the n is greater than 30, and then this is the margin error, how we want to calculate it, right? So this is plus minus 195, 196 is actually for 95% confidence level, right? And then this one is actually the standard deviation that we calculate from the sample, right? Okay, so this is standard error. Okay, standard error, remember when I say we need to write our distribution before, okay? So we get X is distributed n mu and sigma square. Okay, this one is actually for the population. Okay, and then if we have n, we take some n from the population, it become the mean sampling distribution with mean x bar and sigma x bar square, right? Where the sigma x bar square is actually sigma divided by square root of n. So this one is actually standard error, okay? Or we call it a standard deviation for sample, right? So usually this one we also can represent as S, right? So people just want to emphasize the difference. What does it mean by standard error? Standard error is actually standard deviation for sample. So we want to differentiate, we want to differentiate standard deviation for population and for sample. We name it differently. We call it differently. For the population, we call it as standard deviation. And for the sample, we call it as standard error. Okay, so this is example, right? A random sample of n is equal to 50 mils showed a mean average daily intake, okay, of dairy products equal to 756 gram with a standard deviation of 35 grams. Find a 95% confidence interval for the population average M. All right. Right. So let's say, okay, when I say when you read question, make sure you circle or highlight all the numbers given. Right. So this one is actually the question. We leave it first. Okay. So the first thing that we want to do is actually we need to start whatever questions given with the distribution. You need to write the distribution first. Okay. So in this case, right? Oh, so we have X, right? Right, I write it here, and mu and sigma square, right? So we have X, okay, and the mean given here is actually 256, okay, 256, right? And then we have 35 gram for the standard deviation, 35 square, right? So this is how you need to start, right? So then you need, since we have n is equal to 50, so it means that we need to do inferential statistics because
Madam,
we are using sample in our study.
Madam,
So, yes.
isn't it 756?
Oh, okay, thank you. All
Alright.
right. Okay, okay, 756. All right. Thank you. Right. So then we have the mean sampling 756. Okay, remember this number, these two number, it will be remain the same because the mu and the x bar will be same. The difference is only this part right here, the standard deviation for the sample and also population. So now we can calculate, for example, let's say I call it as SE, or I can call it as sigma x bar. Okay, so it will be sigma divided by n. So sigma in our case is 35 divided by square root of 50. Okay, can somebody calculate it for me? What is the answer? 4.96. Thank you. 4.95. Is it 95? Okay, thank you, Esther. 4.95 square. So this is the new distribution that you get for your sample. This is how you calculate your standard error, right? Just exactly the same like what we did in our chapter 5, right? Okay, I leave the, I'm not going to do the 95% confidence interval yet, all right, because I need to explain what does it mean by 95% confidence interval and so on. But for this chapter, right, you need to be able to answer or to find how to calculate for the confidence interval. When I say you need to calculate for the confidence interval, your answer should be later on in bracket, lower bound and upper bound, close bracket, right? So your answer should be in this format, right? So you have the lower range and the upper range, okay, for the answer. Okay, now let me explain to you how to calculate this confidence interval, right? Okay. So confidence interval. So what does it mean by confidence interval? So the error will be this part right here, okay, which is we call it as alpha, right? Alpha known as also error. So it means that when I sheet this part right here, okay, so it means that, right, the area that I have shaded is, I call it as the area that I'm not confident. The area that might occur error from my estimation. The one that I really confident will be at the center, and it must represent at least 95%, 90%, 95% of the whole area. Okay, if this area, okay, the one that I shaded, the total is alpha, then when I divide it into two parts with left and right tail, so the alpha should be divided by 2. Okay, so and then the area, the one that I did not shade, so that one will be 1 minus alpha. Why is it 1 minus alpha? Can somebody tell me? Why this area at the center is 1 minus alpha? Anyone? Ada siapa yang nak cuba? By the way, I'm on page 71 now, right? Okay, why is it the center here, this area right here is 1 minus alpha? 1. Probability half of the graph. Okay. So what does it mean? Anyone? Ramla, where are you, Ramla?
Yes, dokter.
Okay. Dah habis raya dah, Ramla?
Dah.
Dah. Wah, cepatnya orang kat sana dah habis raya, orang dekat Semenanjung tak habis lagi. Okay, Ramla, kenapa dekat center ni we call it the area 1 minus alpha?
I think it is because the alpha is around the error. So 1 minus alpha.
Kenapa? Why 1 minus alpha?
Because overall is 1
Okay.
and both side is the error, which is alpha. So
Okay.
to get the value, we minus 1 minus
Uh,
alpha.
yeah, pandai, sangat pandai. Correct. Okay. So remember the total area under the curve is actually represent probability, and the total of the probability is equal to 1. And then the shaded area is actually represent the error, which is alpha. The total is alpha. Therefore, the remaining part of the center will be 1 minus alpha. 1 is the total of the probability minus the alpha, which is from the right and the left tails. Okay? Okay, very good. Okay, let's say, okay, if I say this one is 95%, okay, the center, the area at the center is 95%. What is our alpha? What is the value of alpha? In terms of percentage? Anyone? What is actually the value, total value here? 5%, yes. So our alpha here will be 5%, right? Because it is the remainder of 95%. And then remember, because we divide the tails into two parts, we have left and right. So we need to divide the alpha by 2. So how many percent this area? Let's say the right area. How many percent? Yes, 2.5%, right? So here also 2.5%. So when we add them up, okay, so we will get 100%. So you need to understand the concept of, alpha and alpha divided by 2 and 1 minus alpha. Okay, I give you another example. Okay, let's say the area in the middle is 98%. What is our alpha? Yes, 2%, right? So then our alpha will be 2%, okay? And then how about our alpha divided by 2? 1%, okay? So that's how we calculate, in terms of the percentage of the given alpha, okay? And 1 minus alpha. Right, so in this case, right, so as I mentioned just now, that when we have 95%, it means that this one will be, okay, this area will be alpha equal to 95%. But usually what we did, okay, we write the value of alpha in terms of the decimal point. We don't put alpha is equal to 5%. We don't do like that. Instead, we write the value of alpha like this. 0.05 is actually equal to 5%. Okay, and then the same thing here for our area 1 minus alpha will be 0.95 0.95. Okay, so that's how we need to write our alpha and so on. Okay, let's move on to the next one, confidence level. So you already understand what does it mean by 1 minus alpha, alpha, and so on. Okay, in your table on page 71, I just want you to draw something like this, okay? So just a small one, all right? So you understand what does it mean by 1 minus alpha, okay? This area is 1 minus alpha, and then alpha can be like this, right? Okay, our alpha. Okay, so this is our alpha, just one side, or this one, right? And then we have alpha divided by 2, okay? Okay, we need to have one more column actually, alpha divided by 2, okay? So this one you need to draw like this, right? So, okay, I would like you to add one more column after alpha, which is alpha divided by 2. Okay, is everybody okay? Right, so let's go through how do we get all the numbers, okay? So all this Z, if you can see the value of Z is actually known as critical point, critical points, okay? Sorry lah, Penny mungkin not really clear. Okay. So if let's say we are using the same concept like what we did just now, okay? So the first one is 90, right? So when we have 90, so it means that the center, okay, the center will be 90%, right? So our alpha, in this case, our alpha will be 10%, right? So 0.01, sorry, 0.1. And then this one, alpha divided by 2 will be 5%. Okay. So this one will be 0.05. Right. So and then in order to get this number Z alpha and Z alpha divided by 2, okay. So Z alpha, so for a time being, I would like the blue column I'm not going to discuss for a time being. So I'm going to focus only alpha divided by 2 because this one is actually, okay, this part right here is negative of z alpha divided by 2 and this one z alpha divided by 2, right? So this part right here is actually the critical point that we need to find the value from the table, right? So this one, okay, if the 1 minus alpha is 90, and then the alpha is 10%, and the alpha divided by 2 is 5%, it means that the critical value here for the Z will be 1.945. Okay, so how do I get this number right here? Okay, so when I look at the table, right, so I need to get a number which is close to 0.05. We already did this one in our exercise in our normal chapter, normal distribution chapter. Okay, so I need to find number which is close to 0.05. Okay, 5%, right? So I get this one 1.64 and 1.65, right? So remember I told you that the best number is actually between these two numbers. When we add these two numbers and then find the average, we will get actually 0.05 here. 0.05. Okay. And then the same thing here. This number, we need to add them up and divide by 2. So we will get 0.45. So that's the reason, okay, this number become 1.645, right? So that's how we get this number right here, okay? The critical value, negative 6.45, and then the positive part will be 6.45, right? Okay, I really hope that you understand. The same thing for the 95%. Why is it 1.96? Okay, because 0.025, okay, sorry, 0.05, when we divide by 2, we will get 0.025. Okay, we go down here, okay, and then we will get the number 0.025 will be 1.96, okay. So that's how we get this number, 1.96. So anyway, the good thing is, in your test and also your final exam, this table will be given, okay, will be provided to you all. So then you can simply use all the number in the table, but you need to understand what is actually the numbers here means, okay? You don't just simply take the number, but you don't understand what actually all this number in this table represents, okay? All right, so that's how, okay, the same thing for 0.98, okay, when we divide alpha divided by 2, so we will get 0.01, and then this one 0.05, and how do we get this 2.33? So we need to look at the number which is close to 0.01 from our table. So 0.01, so if you look at this one, it will be 0.0 apa tadi? Sorry. 0.01. This one. Okay, the closest one. So that's how we get for the critical value, the Z value is 2.33. Okay, that's how we find out the number. Right. So the next one, we move to the bottom page of 71. And before that, I would like you to, okay, this one is on bottom page of 71. So the confidence interval, remember, for this chapter, the purpose is to find out or to calculate the confidence interval. When I say confidence interval, what does it mean? Your answer should be in bracket, lower bound, comma, upper bound. Okay. So how can you calculate it? Right. So you must have your point estimator. So what is point estimator is your X bar, okay, plus minus Z alpha times standard error estimator. So this one you get it from the table, okay, and then this one you get from your distribution. Okay. Right, so that's how you can get all the numbers that you need to calculate in order to get the answer for your confidence interval. Okay, so I would like you to write this one in the box on page 72. Okay, on page 72, I would like you, there's a box for the confidence interval. I would like you to write this one. Okay, write this one in your box. Okay, once you're done, let me know. Okay, thank you, Anu, for always being my loyal respondent. Okay, right. So thank you, Atika. Okay, thank you, Zulaika. All right. Okay, so let's move on. So let's do question example so you can understand what actually, how to apply what we have just discussed. Right. A random sample of 100 observation is selected from a population with a mean 143.72 and a standard deviation of 14.8. So we need to construct a 95% confidence interval. And then B, what does the phrase 99% confident mean, right? So as I told you before, so once while reading your question, make sure you circle all the information given in the question in terms of the numbers, all right? So and then before we can answer part A and also part B, so the first thing that we need to start with is actually with the distribution of the question, right? So just write it down. So we have n is equal to 100, and then we have the mean, all right? The mean X bar is equal to, sorry, I keep looking at this one, 143.2, 143.72, and then we have the sigma, okay, is equal to 14.8, right? 14.8. So we need to write the first distribution is like this, 143.72, and then 14.8 square, right? So that's our first thing that the first step that we need to do, right? So and then, sorry, no x bar, just x. Right, and then since we have n is equal to 100, then we need to find the sampling mean distribution, and 143.72 remain the same. So now we need to calculate the standard error or sigma x bar, which is sigma divided by square root of n. So, and then we need to do this one, 1.48 divided by 100, or this one quite easy. So we need, we're going to have 1.48 square. Right, so once you get the new distribution, make sure you box it, right? So you know that for the next question, you need to use whatever in the box, okay? The distribution in the box. So is everybody okay? Right, you also can use a page space in on page 75, okay? If you don't have enough space on page 74, so you have a lot of, space on page 75. Okay, next one, right. So now we need to construct a 99% confidence interval. So the question is we need to construct 99% CI. Okay, so using the formula that I have asked you to write in the box just now, so the CI is equal to x bar, okay, plus minus z alpha divided by 2, okay, times x sigma x bar or xe, okay. Then this one x bar, you can get it from here, from your question, from your distribution, 143.72, okay, plus minus, okay, z alpha divided by 2, I keep it first, and then sigma or SE is 1.48, 1.48, right? So those two information, we can get it from the distribution that we have written just now, okay? And then the next one is for the 99% confidence interval. So we keep this on going. And then we need to find this Z alpha divided by 2. We just take it, the value from the table. So we need to have, okay, 99%, okay, 99%. And we just take for the Z alpha divided by 2, which is 2.58, and then just plug in the number in the equation just now. So 2.58.1.48, right? So this is how it looks like. Okay, is everybody okay so far? Okay. Okay, thank you, Nabila. Right, 99% CI. So remember that we need to get, okay, we need to give our answer, as I told you before, in lower bound and upper bound. So how can I get the number for the lower bound? Listen carefully, okay, so you won't make any mistake after this. Right, so in order to get the lower bound, this part right here, okay, what you need to do, you need to minus the right part, okay, then you will get the lower bound. For the upper bound, the left part, you need to add, right, to get the upper bound. Okay, so I want, okay, Fernandika. Are you here, Fernandika? Fernandika, are you here? Okay, tak jawab. Zichin. Zichin, are you here?
Yes, doctor.
Okay. All right. So I want you to get me the value for the lower bound. Okay, the left minus the right part. Okay, get me the answer. And then Mikael, are you here, Mikael? Tadi saya nampak nama anda. Priyanka, are you here?
Yes, doctor.
Okay, Priyanka, can you please calculate for me for the upper bound? So the left part plus the right part. Okay. Okay, can you please give me the answer?
Doctor,
Yes.
can you show the previous slide?
Okay, can you give me the answer, please?
Doctor,
Yes,
for the LV is 139.90.
like this.
Yeah.
Okay, great.
Doctor, for UV 147.54.
Okay, class, please make sure your friends have given the correct answer. Don't just simply, copy down whatever they have given to you. Right? Thank you, Roha. Thank you, Kirti. Right. So if you agree, this one is the 99%. This is how you write it. 99% CI is equal to this lower bound and upper bound. So once you get the answer, you need to draw this graph, this curve. So otherwise you won't get full mark for it. So this one, the center will be 143.72, which is the mean that we got. Okay, the lower bound is 139.90 and the upper bound is 147.54. So this area right here is 99%, right? So that's how you need to answer your question if I ask you how to find out the CI, right? Okay, so let's go to part B. What does the phrase 99% confident mean, right? So 99% confident mean, it means that no matter, who the researchers are, for example, I might, okay, let's say, I give example, Harsha, okay? So let's say Harsha is doing is doing a study, a research on the same population and taking the same number of sample from this population, 100 people. Okay, so we don't know actually how many n, yeah, the big N, the population number. So let's say Harsha take 100 people from this population, and then Jiajuan, let's say, also do the same study for the same population, and Jejuan also take another 100. Okay, let me tell you, when we do sampling, Harsha and Jejuan maybe take the different sample, different people, but from the same population. Okay, but no matter what, if they are doing the same population, taking the same number of sample from that population, I am 99% confident that they will get their mean, their average. When they calculate the mean will be, okay, within this number right here. Okay, this 139.90 and 147.45. Okay, so the mean that they will get will be 99% be in this range. Okay, so that's what it means by 99%. Okay, let me simplify it for you or summarize it for you so you can write down the answer for part B, right? So are you ready? Just copy down whatever I say, right? So the 99% confident means, all right? Salin, please write down. 99% confident means when different researchers, doing a study, okay, using the same population, taking the same number of sample, okay, 99% they will get the mean for their sample or for their study, okay, within 139.90, okay, within 139.90 and 147.454. Okay, or you can say from 139.90 to 147.54. Okay, so it doesn't matter who wants to do a study on that population, but they must take the same number of the same number of sample, and then when they calculate the mean, they will be definitely 99%, they will get their mean within these two numbers, right? Okay, I would like you, before we take a break, okay, I would like you to try exercise 5 first, okay? Sleep duration may be an important factor of body weight and metabolism. A study involved 1,000 participants found that short sleep duration, blah, blah, blah. And then a random sample was selected from this population and gave the mean of 6.2 hours with the following information, right? Okay, you need to construct a 98 percent confidence interval. Right, people, you need to start with the distribution first. Okay, tell me first. Okay, what is the mean here that you need to take? Anyone? Shafika? Berapa mean kita, Shafika?
6.2.
Yeah, 6.2. Right? And then how about kita punya standard deviation? Okay, kat sini dia tak kasih you sigma tetapi dia kasih you S dan you kena gunakan yang itu. Right? And then you need to continue from here. Okay, don't, jangan tertipu ya. Please, which end do you need to take? 1000 or 200 people? When you calculate the standard error. Number, yeah, which one? We have big N or small n? Yes, correct. We need to take 200. Right, so try to do it. And then you can check your answer on page, the next page, on page 75 for the answer. Please do it now. Okay, session 2, meanwhile, you can scan your attendance. Okay, di samping tu, okay, okay, for those who already done with exercise 5, you can take a break and then I'll see you again. Sekarang ni is 12:20, okay? 10 minutes for you to take a break. Okay, section 1. Okay, can we start now? Okay, thank you, Anong. Thank you, who you, where you. Okay, so may sebut je nama. Right. So now, okay, we already actually, basically, we already finished chapter 6. Now, we're going to continue with our chapter 7. Okay, for your information, chapter 7 is very, very important, okay, because we need to use it, okay, to use whatever knowledge that we gain from this chapter 7 for our next chapters, and also especially for our SPSS later. Okay, starting from chapter 8, okay, we will use, SPSS, quite a lot after this, all right? So, in order to answer all the questions in chapter 8, 9, and so on, we will use SPSS. Okay, your test will stop until chapter 7. Okay, chapter 8 onwards will be covered in your final exam. Right. So let's continue with chapter 7, hypothesis test, right? So what does it mean by hypothesis? So when do we need to use hypothesis? So hypothesis test can only be used when you have sample in your study and when you are doing inferential statistics in your study, right? So there are two types of hypothesis. So the first one, we call it as null hypothesis. So 0 is null hypothesis, okay? And then, so we call H is hypothesis 0 null. And the second one is known as alternative hypothesis, or we call it as HA, hypothesis alternative. And some of the statistic books, instead of using A, they use H1 because after 0, the opposite of 0 will be 1. Okay, but for my class, for my students, I prefer to use HA. Right. So in other words, what I can use this way in order to make you understand better. Okay, how pula? Null hypothesis. Okay, HO. Okay, HO. I can call it HO is hypothesis orang in bahasa, or hypothesis other people. Okay, whereas HA ialah hypothesis aku, my hypothesis. So this is how I explain to student and how to make you understand. When you are writing HA is actually your hypothesis, what actually you want to say, what is actually your claim is, right? So hypothesis, in other words, is claim, or in Bahasa Malaysia we call it dakwaan, what we claim to be, all right? And if you write HO, so HO is actually represent for other people say, what other people say, what orang kata. Usually when we say something, other people will say something else opposite to what we have said. For example, I said, I am the best person in the world. Mesti ada orang akan kata boleh blah lah. Okay, I don't think you are the best. There are some other people who is better than you. Okay, for example. So usually what we can say, other people will say something which is opposite to what we say, right? So, but in our hypothesis testing, when we want to do it later, okay, so the one that we are actually tested is hypothesis other people, not hypothesis us, right? Because usually the society, okay, our society will believe more other people rather than believe us, okay? So for example, if I claim that I am the best person in the world, so let's masyarakat, the society will say, I don't think so. You are the best, okay? But if there is someone in the society said that, hey, actually, she's the best in the world. I have research, do a research, and I found that she is the best, for example, then the rest of the society will believe me because of that one person. So it's normal, okay? It's normal in our society, right? So how do we write the hypothesis? Okay, the first thing that we write for the HO, okay, the HO, okay, for orang or other people. So we remember we are doing the hypothesis and we are trying to estimate the mu, right? This is our job to estimate mu. Okay, we estimate the mu equal to whatever, right? And hypothesis aku or alternative hypothesis mu can not equal sign greater than or less than whatever. Okay, this one is whatever. So whatever depends on the question, right? So HO can only use one symbol, one equation, which is equal sign. Whereas HA, we can write not equal, greater than, or less than, right? Why HA has more alternative or more options? Because this is our study. So we can say whatever we want, but not other people, all right? Okay. So please write this one down on page 76. Okay, once you're done, let me know. So we can move to page 77. Okay, thank you, Anong. Okay, thank you. Right. Okay, thank you, Wenjuan. Okay, so next one. Thank you, Sha, what? Sh, macam mana? Ya Allah, cannot sebut nama you. Syari. Ya Allah, susahnya nak sebut nama. Okay, errors in hypothesis test. Okay, when we are doing estimation, it is normal to do mistakes, to do errors. Okay, because sometimes it says here because the sample data are not completely reliable. Remember when I give you example on the for the 20 houses. So might be, some of the prices given to us is not reliable. And there is always the risk that misleading data will cause the hypothesis test to reach a wrong conclusion. So when we say, when we blame other people, they are wrong, but actually what they say is correct. And sometimes people believe us. People thought we are right, but actually we are wrong. Okay, so it's normal. So in order for the errors that we may make during this estimation or hypothesis test, so there are two types of errors. One we call it type 1 alpha, type 2 is beta. Okay, so this one alpha is A, I put it as a not, right? And B, I put it as blessed, right? So this is what happened. So if sometimes, when we disagree with someone, we say someone is wrong, but actually that person is right. So that one will be type 1 error. Type 2 error when we actually agree with someone, but actually that someone, tipu us or cheated us, that someone is actually wrong, but we believe that person. So that is type 2 error. So and this is how it looks like when we reject H naught, but actually H naught is true. When we reject other other people's, hypothesis or claim, but then actually the hypothesis is true. This one we accept that person's, okay, that person hypothesis or claim, but actually that person is not right. Okay, so there are two types of error that we may make during this estimation. Right. So, and then the next one I would like to explain in terms of rejection and non-rejection region. Okay, we already discussed just now in chapter 6 regarding the critical value or critical point, which is represented by Z. Okay, so Z, it depends, okay? It depends on the question. So Z can be negative or Z can be positive, all right? So and the value of z we can obtain actually from the normal table, okay, from the normal table. And then for example, just now we know that in order to get alpha is equal to 0.05, where we get 95% confidence interval, the z value will be 1.96. How do we get 1.96? Is actually from the table. And then for the alpha, 99% confidence interval, the Z value will be 2.58. And for the alpha equal to 90, this one, okay, 0.90, okay, 90, 0.0101, for example, the Z value will be 3.3, okay? So uh, this is what actually the critical or the Z values, okay? How do we get or determine the critical value of points, okay? And then the next one, um, level of significance. People, this one on page 77. Okay, the level of significance will be alpha. Okay, alpha, as I mentioned before, is actually to represent the error. Okay, so alpha should be written in decimal point, not percentage. For example, 0.01, alpha 0.05, or alpha point 0.1, for example. Okay, so you need to write the alpha or the error in terms of decimal point, but it represent for the percentage. This one for 99%, this one for the 95%, this one for 90%, for example, right? And then the next one, the alpha level. So same thing just now. The alpha level establishes a criterion or cutoff for making decision about the null hypothesis. So as I mentioned before, it must be written this way. And the alpha level also determines the risk of type 1 error, where we accept we reject what other people say, but actually what that person say or what that person claim is correct. Okay, so I would like you to write this one down on page 77. Okay, I give you 2 minutes to write this one down. Okay, Alifa, okay ka?
Okay, Doctor.
All right. Okay, let's move on to the next one. Okay, rejection region alpha. Okay, alpha, remember, alpha represents for the area of error. Okay, so the error, we can also call it as a rejection region, where we need to reject. Okay, remember just now in our table, for the confidence level, we have Z alpha and we have alpha and alpha divided by 2. So if we only have alpha, so it means that only one-sided, okay? So for example, if here we have alpha, so the alpha will only on the one tail, okay? One side of the tail. And if the alpha on the negative side, it means that it only has one side of the tail, right? So this is what we call it also rejection region. Okay? And we also have condition where we need to divide alpha divided by 2. Okay? So in that case, we have the alpha, right? On the left and also the right tail, but the total of these two alpha will be these two tails will be alpha, right? So this one especially important when we want to calculate for the CI, right? Just now, important for the CI. Okay, next one. Okay, non-rejection region. The opposite of rejection region, alpha, is non-rejection. Non-rejection region also means confidence area, the area that we are confident and represent by 1 minus alpha. Okay, you already understand what does it mean with 1 minus alpha in our previous chapter. So non-rejection region will be this area right here. Okay, because the tail will be the error, so the center will be the focus area will be non-rejection region, or sometimes we call it as acceptance region. Alright, next one. Two procedures to make tests of hypotheses by using these two approaches. One, we call it the p-value approach. The other one is the critical value approach. The p-value approach usually be used when we use SPSS. So in SPSS, this p-value is called as significant value. Or in SPSS, the short form will be sigval, right? And then the critical value approach is usually we use table or manually. We use the statistical table like the normal table and so on, right? So then we use the critical value approach by getting a Z value, right? For example, getting the Z value from the table. So that's what we call it as critical value. Okay, is everybody okay? Right, next one, tails of a test. Okay. Okay, this one p-value. So p-value is also known as significant value sigval in SPSS, all right? So, right, and then the critical value. Okay, hypothesis. When do we need to use hypothesis? When we have a sample in our study, and the treatment is administered to the sample. Whatever it is, we must have a sample. Then we can use the hypothesis test. All right. So let me tail of the test. See, hold on. Okay, tail of a test. Okay, so remember just now we have either alpha or alpha divided by 2. So when we have only alpha, then we have one tail. If we need to divide the alpha by 2, so that one will be 2 tail because it has on the left and the right side. Okay, so what does it mean by one tail and two tail test? How do we want to decide whether we need to use one tail or we need to use two tail? So it all depends on your HA. So your HA is very important in order to tell you whether you need to divide your alpha by 2 or not. Okay, so two-tail test, it means when you have left and right, where your alpha needs to be divided by 2. So when do we need to use two-tail? When our HA use not equal sign, right? So if we have not equal sign, so it means that we need to use two-tail. If we have our HA greater than, so it means that you have one tail but on the right side. Okay. If you have less than, so it means that you have one tail but left side. Right? So that's how you decide your one tail or two tail. So so I would like you to write all this on page 78 and 79. Okay? Right, so let's do exercise. Okay, on page exercise 1. I'm sorry, exercise 1 first. Okay, as exercise 1, write the null and alternative hypothesis for each of the following example. So you need to write the null and alternative hypothesis. Okay, so let's do number 1. Okay, let's do number 1. Okay, we are asked to write the hypothesis, the null and alternative hypothesis. Okay, this one part 1. Okay, so it says that to test if the mean salary, so the clue there is the word mean. So we have mu, right? So we just write mu here. Okay, and we know that the null hypothesis always have equal sign, right? And then it's just that we need to decide which symbol we need to use for the HA. So it says that the salary of part-time workers in the fast food restaurant is different. Okay, different from RM14. So RM14 here. So what symbol is actually best to represent the word different? Anyone? What symbol should we use for different? Not greater than, no. Different, not equal. Yes. Thank you, is fine. Not equal. So that's all your answer for number 1. Okay, I would like you to try for number 2 and number 3. Okay, Zian, give me answer for number 2. Zian, are you there? Oh, tak ada jawapan ni. Anyone? Siapa? Ya, Hasha. Bagi jawapan Hasha. H naught apa?
More.
Sorry, H naught.
H A M.
No, the first one. The first one. Kita kena start dengan null hypothesis dulu.
Equal. Equal,
Okay,
right?
mu equal what?
Equal 1,42881 tons.
Oh, ini itu nombor 3 Hasha. Baru nombor 2.
Okay.
Okay, berapa ni? Nombor 2.
Think less
Okay.
than
Tak. H naught dulu. Ni berapa? Berapa ringgit?
1,000 ringgit.
1,000, okay. And then untuk mu, okay. The clue word kat situ apa?
Just give me. It said less.
Less than, okay. So
than.
less than, so RM 1,000, okay. That's how it looks like. Okay. Right, so number 3. Any volunteer? Any volunteer for number 3? Oh, you all ni bila cakap volunteer semua senyap sunyi eh. Anyone? Bakron. Wujud ke tidak? Hui?
Yes, doctor.
Okay, what's the answer for number 3, you Hui?
Equal, mean equal.
Okay, the first one, H naught.
Mean equal 142S. Oh, mean equal 14281.
Or 28881. Okay, done. And then for HA, what is the clue word? Hui?
More than.
More than. So the apa kat sini? The clue word kat sini. It doesn't say more than. What is the clue word?
Can improve.
Can improve. So can improve. So more than 1428881 tons. All right. So that's the answer. Okay, so let's do exercise number 2. All right, exercise number 2, you want us to explain of the following is two tail test, a left tail test, or the right tail test. Okay, so I'll do number 1 about part A. All right, so when we want to decide in terms of the tail test, right, so we need to just focus on that HA. We don't even need to look at the HO. All right, so HA, mu greater than 35, right? So HA, mu greater than 35. So is it one tail, two tail, or what? All right. So what do you think? Alif. Oh, Alif.
Yes. I
Okay.
think it's
All right.
one
So
tail.
mu greater than 35. So here is greater than. So is it one tail or two tail?
One tail.
Okay, is one tail. Left or right?
Right.
Right. So it's right. So then it means that your letter, it will be here. Okay, your right tail. So it's only have alpha. All right. So how about B? Sabrina. Oh, Sabrina, where are you? Tak wujud. Nurul Basira.
Two tails
Okay, two tail. Kenapa two tail?
sebab simbol dia not equal.
Okay, betul. Sebab simbol nak equal. So two tail. Okay. So tak ada left or right lah. Maksudnya dia memang ada left dengan right. So it will look like this. Okay. Alright. So how about part C? Puyi. Puyi, are you here? Okay, tak ada jawapan. So, sorry, Esther, I saw you something.
Yeah, no, doctor, because your pronunciation of the name is a little confusing.
I see. Tak reti apa salah Alright. Okay, so okay, I'm so sorry. So, but I'm still learning how to pronounce all the Chinese names. Right. Okay, so what's the answer, anyone? C? But C? What is the clue word there? Cepat habis ni, kita boleh habiskan kelas dah. Different from, yes, two tail. Okay, thank you. So different. So the word different, so it means that the HA has not equal sign. So not equal sign is supposed to be one or two tail. Okay, orang yang sama je ya kan jawab kan, two tail. Alright, thank you. Right, so the gambar raja will be exactly like this. Okay, macam yang bahagian nombor 2. Okay, last one, part D. To test the mean profit of a satay stall is less than 250 a month. Okay, so what is the clue word there? Tariq. Ini semua less than. Okay, thank you Liana. Diorang ni semua makan kuih raya tak wujud dalam kelas ni. Okay, so less than. Alright, so it's supposed to be one or two tail. Okay, one tail, correct. So one tail left or right? Left. Okay, thank you. Right, so so the last one, D, so it's supposed to be two tail, so left side. Right? So because of less, that's all for today. Right, so on Wednesday, so I'm going to continue a little bit, okay, on this hypothesis, because we need you to use this hypothesis starting from our chapter 8. And then I'm going to introduce a bit on chapter 8 also. Just preliminary before we can start with our SPSS analysis, all right? So chapter 8, we start using SPSS for all the questions in that chapter. Right, so in that case, okay, so I'll see you again on Wednesday and get ready for your quiz I will let you know. Okay, the quiz will cover until what, which chapter and so on. Right. So I think it's still apa? Okay lah untuk to wish you all selamat hari raya. Maklumlah raya ni sampai sebulan. Selagi tak kenyang dengan kuih raya, people keep visiting friends and also relatives. Okay, so I'll see you again, people, on Wednesday. Thank you very much. Okay, for being here today. Okay, bye bye. See you all on Wednesday.
Thank you, Doctor.
You're welcome.
Bye.
Okay, bye.
Thank you.